Going forward, let's proceed with the fourth chapter, water-miscible quenching media, also known as polymer quenchants. In this chapter, we will discuss the following: development and usage of polymer quenchants and the two types of polymer quenchants, inverse solubility polymer quenchants, up concentration polymer quenchants. Let's proceed and discuss. We begin with polymer quenchants. We shall cover the following: development of polymer quenchants, advantages over emulsion, substitution to oil quenching, comparison to oil cooling rates, incombustibility. As has been shown, quenching oils cover a wide range of cooling performance, yet there is still a significant gap between the maximum achievable cooling rate of a low-viscosity accelerated oil and that achievable with the ordinary cold water. Water-miscible quenchants, which fill this gap, are thus an ideal complement to the quenching oil range. Heat treatment operation can be carried out with these water-based quenchants, which would either be impossible or extremely difficult with oil. This particularly relates to spray quenching in induction and flame hardening processes, where a high degree of fire risk exists when using oil. Emulsions have historically been employed in these applications instead of oil, but unfortunately, they do not give the low cooling rates in the temperature range for Martensite transformation necessary to reduce or eliminate the danger of cracking. These cooling characteristics can only be achieved with polymer quenchants. As a result of our continuous development programs, we are today able to offer users a complete range of water-miscible quenchants which successfully covers the whole spectrum from oil to water quenching. Accelerated quenching oils can already be replaced in a wide range of applications as polymer solutions are available, which give comparable cooling characteristics. These solutions are therefore suitable for hardening alloyed quench and tempering steels and some tool steels, as well as for quenching components directly from forging. Water-miscible quenching media are today used to a high extent as a substitute for quenching oils. It must be realized that these products contain from 60 to 98% of water in the ready-to-use condition, the level depending on the concentration to be used for a given application. Due to high water content in polymer quenchant solutions, the cooling rates in the boiling phase are usually higher than the cooling rates in quenching oils. All water-miscible quenchants are of course incombustible and, in contrast to oil quenching, helps avoiding the risk from fume and fire. This is particularly useful when hardening forged parts directly from forging temperature and for interrupted quenching, that is, time quenching of components. Hardcastle Petrofer has rich experience of formulating and manufacturing polymer quenchants. The wide range of polymer quenchants available provide the users the choice of options to suit their performance requirements. These polymer quenchants can be used in a wide range of concentrations in water. This property provides the users with the flexibility to use the same polymer for quenching of a variety of steel grades and also for use in induction hardening as well as tank quenching applications. By careful selection of high-quality raw materials, the efficient performance is ensured. Hardcastle Petrofer polymer quenchants exhibit very high level of thermal stability, thus providing consistent performance over a long period. High-quality corrosion inhibitors, biocides, and defoamers help effectively control and maintain the quality of polymer solution in use. The use of water-miscible products can often be a new venture for customers, and therefore it is advisable to discuss applications thoroughly. This is obviously not so important with induction and flame hardening operations, where the use of water-miscible quenchants has been established for many years. However, for other applications, we recommend consultation with our technical service representative to make use of our extensive experience in this field. This is particularly important if a quenching oil is being replaced. Firstly, it is very important to provide the performance requirements of the applications to the technical representative of Hardcastle Petrofer. Secondly, it is also important for the user to provide complete information on steel grades, parts geometry to be quenched, the hardening process used, as well as the quench system. This enables our technical representative, who has extensive field experience, to recommend the most suited polymer quenchant grade. We shall now move on to a discussion about the two main types of polymer quenchants, namely inverse solubility type polymer quenchants and up concentration polymer quenchants. Inverse solubility polymers exhibit inverse solubility in water. That is, they are soluble in water at room temperature, but insoluble above the inverse solubility temperature, normally 65 degrees Celsius to 70 degrees Celsius. These polymer solutions reduce the quenching effect of water by virtue of the polymer in solution becoming insoluble at the inverse solubility temperature during the quenching process and plating out onto the hot surface of the component. The thickness of the insulating film formed varies with the concentration of the polymer in the original solution. When the component cools to below the inverse solubility temperature of the polymer solution, the film starts to redissolve completely, thus ensuring the drag out of the polymer to remain low. Hence, these polymer quenching solutions are very economical in use. Inverse solubility polymer quenchants are used in quenching baths, mainly for hardening low alloy steel grades, quench and tempering steels, which are difficult to harden with quenching oil, but which are prone to cracking with water quenching. They can also be used for induction and flame hardening processes. Inverse solubility polymer quenchants can be used for a wide range of applications. Quenching of forgings of low alloy and plain carbon steels for automobiles. For example, crankshafts, connecting rods, camshafts, etc. Quenching of steel castings. Quenching of bars, sections of low alloy and carbon steels. Hardening of hand tools, spanners, wrenches, tongs. Hardening of high-pressure cylinders and seamless tubes. Hardening of carburized or carbonitrided small parts in continuous furnaces, chain and bicycle components. Induction hardening of crankshafts, camshafts, gears, splines on shafts, slewing rings, axle shafts, velocity joints, etc. Inverse solubility polymer quenchants are also used for solution heat treatment of aluminium. Typical applications for aluminium are sheet panels and sections in the aerospace industry, castings and forgings used in automobile industry. For example, cylinder heads, engine blocks, alloy wheels. Hardcastle Petrofer has a major share of business in India for their inverse solubility type polymer quenchants. These quenchants are classified according to their respective kinematic viscosity at 40 degrees Celsius. We generally recommend the application temperature in the range of 25 to 55 degrees Celsius. Amongst the products shown in the table, HighQuench P11 and HighQuench P12 are used by a large number of customers in India for induction hardening as well as tank quenching applications. The two products, HighQuench P122 and HighQuench P21, are used where the application requirements are very demanding. Hardcastle Petrofer also has special grades of polymer quenchants which are used for solution heat treatment of aluminium parts, such as sheet panels and airframe section in the aerospace industry, and for castings and forgings of parts such as cylinder heads, engine blocks, alloy wheels, etc., used in the automotive industry. The new generation up concentration type polymer quenchants provide an even more significant reduction compared to inverse solubility polymer quenchants in quenching speed when added to water at various proportions. Concentrations of 8 to 20% give cooling curves practically equal to those of quenching oils. Reduction of the quenching rate compared to that of water is achieved by the formation of a polymer film on the part surface during cooling. In the beginning of the cooling process, a thin polymer film ensures uniform collapse of the vapor blanket and the start of the boiling phase. With further cooling, an insulating film develops, and the thickness of the film varies with concentration. Its insulating effect ensures a controlled heat flow from the component into the quenchant. These polymer quenchants are used to treat steels of higher hardenability, for example, for quenching alloyed, tempering, and case hardening steels, and for hardening tool steels. Interrupted quenching of components is possible at any desired surface temperature. These polymer quenchants can be used for a wide range of applications. Quenching of open die-forged components like turbine shafts, seamless rolled rings, valve bodies. Quenching of bars, coils of martensitic stainless steels. Quenching of die steels, tool steels. Well, we come to the end of the 4th chapter. I hope you are going to take advantage of what you have learned in this chapter. Let's move on to the next chapter.